Okay, so this is lesson 5.2. You know when you guys have graphed before and you have like a vertical asymptote and you have a horizontal asymptote and your graph is in two pieces and it goes different places and sometimes you have a hole. Who says yes? I remember all that. Okay, that's what we're doing and we're leading up to it. Okay, there's a big connection between last time's lesson, this lesson, and the next lesson. Okay, but this one really is the big one. Next time's also quite important as well. Okay. All right, so we are going to graph rational functions. Okay, a rational function, you guys, is a fraction, and there's an x on the bottom. So do you see that y equals 1 over x? I really think of that as the parent rational function. It's a rational function with no adjustments. Okay, everybody tell me out loud. Look at that equation. What is the domain of that equation, you guys? X can't be 0, right? Can't have a 0 on the bottom. You've got an x down there. So x cannot be equal to 0. So write that over on the side. Now, the line x equals 0 is actually an asymptote on this graph. So I want you to take your pencil and I want you to dash in an asymptote. Couple of things. I would love you to get a red pen if you have it. Okay. If you have one in your bag, that'd be wonderful if you could grab it. Even if you don't have a red pen, you could do like a pen, or you could do it with a highlighter. You know, you have lots of options, but I feel like if you pull colors in, it's totally helpful. Okay. Some people are afraid to put that asymptote right on the axis, so they push it over to the side. Don't do that, because if you push it over to the side, then your graph is no longer accurate. Your asymptote is off. So don't be afraid. And then to show that it's an asymptote, you're going to use a different color, and you're also going to extend it beyond the axis so you can see it. Okay? This is something that's important. So everybody look. That asymptote has taken the XY axis and cut it into two pieces. So there's a piece on the right and a piece on the left. So your graph is going to have two separate pieces to it. Okay, so just be aware of that. If you had two asymptotes, then you'd have two cuts, right? And how many pieces would you have, everybody? Three pieces. So always one more than the asymptote. Okay, so we're going to graph this in a very low level manner. I think a table of values is so elementary. But we're going to do it just for this problem, okay? I know I have a graph on the right and I know I have a graph on the left. So what if x was a 1? Then you'd have 1 over 1, which is a 1. So that's the ordered pair, 1 comma 1. So just put a dot right there. What if x was a 2? Then you'd have 1 over 2. So you'd go right 2 up a half. If x was a 3, it'd be 1 over 3. And then 1 over 4, and then 1 over 5, and then 1 over 1,000, and then 1 over 2,000. Is this piece of the graph ever going to touch the x-axis, guys? No. It gets closer and closer and closer, but it doesn't touch it. How about in between a 0 and a 1? Well, let's do like a 1/2. Somebody tell me what 1 divided by 1/2 is. 1 divided by 1/2. It is a 2. Good. It's a 2. So if I go right a half, I go up 2. If I go right a third, I go up 3. Right a fourth, I go up 4, etc., and your graph looks like that. Okay? Now, that's only half. That's the right side, but now we have to do the left side. So on the left side, the x's are negative. So if those are all negative, what does that do to my y? Well, that'd be 1 over negative 1, which is a negative 1. 1 over negative 2 is a negative 1/2, etc. So it just changes the sign. So now let's plot those. Left 1 down 1, left 2 down a half, left 3 down a third, left 4 down a fourth, etc. And it goes like that. And then how about left a half down 2, left a third down 3, etc. Okay? Now, your midterm is 1 month away, just so you guys know. On your midterm, if you do this, look right here, you will literally lose every single point. Watch right here. And that might even be an exaggeration. What if it's like this? Every single point is gone. Why? Why is that a problem? Tell me a couple of things, bud. It's not a function anymore. If this graph really continues in the manner you've said, it's no longer a function. And as the graph goes down, it's supposed to get closer and closer to that asymptote, not further away. So you need to get really, really, really closer. You know, the smaller that x gets, or the closer that x gets to 0, the closer it gets to the line. Okay, now that graph is not complete. There's actually something missing. Do you guys know what it is? Yeah, that's right. What is it, honey?
I forgot.
Yeah, it's an asymptote. Yeah, you've got an asymptote right there because it's also never going to touch the x-axis. Good. So we have this vertical asymptote right there at x equals 0. But you guys, you also have a horizontal asymptote that crosses the y-axis at 0 as well. Okay? Now, there's only one more thing we have to do, and that's to find the range. So range is y, start low, move up. Is the range everything? Tell me that. What is it? You can say it out loud. Can't be 0, right? What can't be 0? Y. So y cannot be 0, and we're done. So that's like the parent rational function. Kind of takes on that look. Yes, honey?
So if you were to write that in interval notation, would you get wrong?
No. No. You write it however you want, unless they tell you otherwise. Okay, so here's what's going to happen. We're going to find like 5 things today, maybe more than 5. And you just have to remember how to find everything. Finding it is not tough. It's remembering how to find it that the challenge comes, I think, for sure. Okay, find the domain. We've already talked about this. When we look for domain, we look for 3 things. 2 of the 3 involve an even root. Do I have an even root on A or B? No. The third one comes from the denominator. The bottom, finish it, cannot be 0. So everybody right here, put denominator cannot be 0. And then I want you to highlight it. Highlight domain, denominator can't be 0. So there's the first thing that you have to remember, which you should already know anyway, right? So everybody go x plus 3 cannot be 0. X cannot be -3. That's your domain and you're done. Do you really have to write x plus 3 cannot be 0? No, you do not. I know that you can do that in your head. Okay, let's do question B. What's the domain? Well, the denominator can't be 0. So you just go x to second plus 3x minus 4 cannot be 0. Then you're going to factor it. So it goes to x and x. The 4 goes to 4 and 1. Signs are different. Biggest is the positive. Looks like that. Everybody write x cannot be 1, comma, -4. Then I want you to put a box around it. And then I want you to take your pencil and I want you to very lightly cross through it. You cannot write it like that. If it's a cannot be equal to, you have to write them separately. So I had a conversation with my last period, and this is what they said to me. When can you write it together and when can you not write it together? Well, when you're solving and you get like x equals 2 and comma 3, it's totally fine. Cannot equal to, you have to write them separately. So you know what they said? Like the whole class agreed. They said, from now on, can you please just always write everything separately? And then I don't have to remember when it can be together and when it can be separate. I'm always just going to separate it. Who says that's what I want to do? Okay, so let's start doing that. I'll be really good about it. And if I'm not, then you guys remind me. Okay, say, can we separate that? Okay, so the way you're going to write that is x cannot be 1, x cannot be -4. I don't want you to put an and in between. I don't want you to put an or in between. I don't want you to put a comma in between. I just want you to write it just like that. Okay? Okay, now we're going to talk about vertical asymptotes. To find a vertical asymptote, all you do is take the denominator and set it equal to 0. There's a second thing you have to have memorized. So if you take that bottom, that denominator, and you set it equal to 0, I get x equals -2, and I'm done. Every single time I teach this, listen what people say. Freeze right here for 2 seconds. They say, up above you told me it can't be, and now you're saying it can be. So which one is it? It doesn't make sense, right? Everybody draw an XY axis. Come over here to a -2. At the line, x equals -2, dash it in. I'm going to ask you a couple of things. Well, I'm going to ask you one thing, and I'm going to say something that's kind of hard to understand. Look, how many pieces will there be to my graph? Tell me. 2 pieces. Do you see that? One on the right, one on the left. Who says I see that? Okay. Listen carefully and see if you can follow what I'm saying to you. You have an asymptote at x equals -2. You can never cross a vertical asymptote. Okay? You can't do it. So, since I can never cross that red line, I'm restricting x from ever being a -2. So x can't be a -2, and it's restricted by drawing an asymptote. Who says I understand what you said? Okay, great. Okay, let's do question B. I want you to write x squared minus 9 equals 0. Then we're going to factor it. We're going to factor it to x plus 3, x minus 3 equals 0. Underneath that, I want you to write x equals -3, +3, put a box around it, and tell yourself, I can't do it like that. If you're talking about asymptotes, okay, listen carefully to this. If the question just said solve, and that was the problem, you could totally do that. But this is different because these are asymptotes. There's no kind of asymptote whose equation is x equals -3, 3. That's not such a thing. So you have to say x equals -3, x equals +3, and you're done. Who says gotcha? Let's see. Okay, great. Question C, vertical asymptote. I'm going to ask you, how do you find, where does a vertical asymptote come from? Everybody in the room is going to say bottom, yeah, or denominator. Yeah. Okay, so everybody go x squared minus 4x plus 4 equals 0. Then you're going to factor x and x. Signs are the same, they're both negative. 2 and 2 multiply to give me 2 and add to give me 4. This guy right here gives me x equals 2. This guy also gives me x equals 2. I don't have to write it twice. I'm done. Okay? I want you to draw an xy axis. There is 0 graphing on homework. But the next time I see you, there is graphing. So I don't want you to freak out when you have to graph. Okay, so I'm starting to lead you to graphing. Okay, see if you can do this. I know you can't see, just see if you can do it by my voice. Go to the right 2. Draw a vertical line that hits the x-axis at 2. How many different pieces am I going to have to my graph, everybody? 2. I'm going to have 2. Okay, that's all I'm going to say about that one. Okay, let's go to question D. I know you can't see. We're going to see how good you guys are at just doing things by voice. It keeps doing it. Like, literally yesterday, it did it every period. So frustrating. Okay, question D. I want you to circle question D because this came up last semester. This is something you need to be careful about. We're going to talk about it in depth the next time. Today, we're just going to kind of touch on it. Okay? Find the vertical asymptote. Everybody tell me how you find the vertical asymptote. Just tell me one word. Bottom, right? Everybody say x squared plus 4 equals 0. Now, do I know how to factor x squared plus 4? Does it factor? It does not factor. So I can't solve this by factoring. I could use the quadratic formula. I would never use the quadratic formula because it's way easier to do it a different way. If you just pull that 4 over, it becomes a negative. So you have x squared equals -4. What would you do now? Square root. So you get x equals, what comes right after the equals if you did it? Plus or minus. And what's the square root of a -4? 2i. Okay. Now let's talk about this. That's supposed to be a vertical asymptote. How do I graph an imaginary vertical asymptote? You can't. So what do you think the answer is? What's the vertical asymptote? What do you think the answer is? There is none. Okay. Now, you're done with that problem, but let's extend it just beyond that. Okay, everybody listen. My last period couldn't quite grasp this. I know you guys are so good at participating, so listen. Look and watch. 1 vertical asymptote, 2 pieces. 2 vertical asymptote, 3 pieces. No vertical asymptote, how many pieces? 1 piece. 1 solid graph, that's all it is. And it actually is going to be, it's going to be like this. I don't know which way it's going to go, but anyway, it's going to be like something like this. Or it could be the other way, something like this. And we could plug in points, but you get the idea. It's just a solid curve. Who says I understand? Okay, wonderful. 1 piece. That's all I need you to understand, okay, at this point. Okay, next one. Vertical asymptotes are either even or odd. So everybody look at odd, okay? If you look at that equation, if someone asked you to find the vertical asymptote, you would take the bottom, set it equal to 0, and you would get x equals -2. Go to those graphs, dash in a -2. Okay? Now, how many x plus 2's do I have on the bottom? What is the outside exponents of the x plus 2? 1. 1 is odd. I don't care if it's 1 or if it's 3 or if it's 5 or it's 7. It doesn't matter. It's going to take on the same behavior. Everybody look right here. When you graph these equations next time, it's just like playing Sudoku. It's like you got this little piece of it, and you got this little piece, and you got this little piece, and you have to remember this, and then you just put the whole thing together, okay? Here's 1 piece you have to remember. Everybody watch. My body is the vertical asymptote. My hands are the graph. This is odd asymptote. Look what happens. As your graph approaches it, 1 goes up and 1 goes down. So they go different. This guy might be up, or this guy might be down. I don't know which, but I know that they go different. Who says I understand that? Okay, so everybody look at this graph. On the left, if this guy went down, if I know he goes down, then I know the other guy, as it approaches it, must go up. The reverse is true. If I know this guy has to go up, then I know this guy must come down. Who says I understand? Okay, it's just part of the puzzle. Look at the next one. Even. Set that equal to 0, you get x equals -2. Grab your pencil, dash in an asymptote at -2. Look at the outside exponent, 2. 2 is even. These asymptotes are even. Everybody look right here. Same diagram. Look. My body's the asymptote, my hand's the graph. Even looks like this. Approaches it, they go the same. So they both go up or they both go down. Right now I don't know, but I know that they're the same. Who says I understand? Okay, great. Look at the left. If I approach here and I know this has to be up, then I know as the other guy approaches it, it also goes up. If I know this guy definitely goes down, then I know this guy over here definitely goes down. Who says gotcha? Okay, yes, honey.
Okay, so I don't know if I'm gonna be able to work this right, but when you're figuring out if the end behavior is it,
It's okay. Try, sweetheart. You're fine.
Is it basing it off of both of the graphs, like one?
That's okay. So here, what I want to do is I want to hold your question until we get to end behavior. And I think I'll be able to answer your question just with the explanation, but I'll touch base and make sure you're good. Okay? That's okay, sweetie. Okay, come back here to question A. We're going back. X equals -2 is the asymptote. It's an exponent of 1. So that guy is odd. So I know 1 goes up and 1 goes down. This guy over here, x equals -3 came from this guy, exponents 1, that's odd. X equals 3 came from this guy, exponents 1, it's odd. Look at example C. This happened to my students about, I don't know, 2.5 years ago. X equals 2 came from here, exponents 1, odd. It's wrong. Why is it wrong? You have 2 of them. So they said it was odd. My students said it was odd, and then they tried to graph it, and then it didn't work out. It wasn't working. It was weird. So just be really careful. X minus 2 times x minus 2 is the same as x minus 2 squared. So that's even. So they both either go up or they both go down. Okay, who says gotcha? Let me see. Okay, great. All right, let's continue. Here is another thing you're going to have to remember. I just love the atmosphere in this class. You're so attentive, so attentive. I'm telling you, that's the ticket right there. Okay, now we're going to talk about non-vertical asymptote. So, not trying to scribble, I'm trying to erase. Non-vertical asymptote is an end behavior. Okay, so non-vertical asymptote is an end behavior. And it's either going to be horizontal or oblique. So I want you to go 1 horizontal and 2 oblique. If they ever ask you what is the non-vertical asymptote, then you're going to first check for horizontal. You know how I'm going to keep drilling you, like where do you find a vertical asymptote? And everybody says bottom. When I say how do you find a horizontal asymptote, everybody in the room is going to say biggest over biggest. That's what you're going to say. And what biggest over biggest means, take the biggest exponent on the top and look at the biggest exponent on the bottom and see what you've got. Okay, so here's the explanation. If they're equal, it's the easiest scenario. You just simplify, or in other words, reduce, and it's just y equals whatever you're left with. That's easy. These two others right here are a little more challenging to look. If the top exponent is bigger than the bottom, then there is not a horizontal, and it's the second option, which is oblique. If the bottom exponent is bigger than the top, then it's y equals 0. Okay? All right, here we go. Another thing that is very important that you understand is you can cross a horizontal asymptote. You know that vertical, never touch it. Horizontal, you can totally cross through it, okay? I'll go more in depth in a second. Okay, determine the non-vertical asymptote. How do you do that? Biggest over biggest. So everybody go y equals. The biggest exponent on the top is a 1. The biggest exponent on the bottom is a 1. So that, take the whole term. So 5x to the first over x to the first. Can I cancel those x's, you guys? Yes or no? Yes, you can. Got one on top, one on bottom. There's 2 people. They both have an x. We're fine. Those cancel. You get y equals 5, and we're done. Who says I'm totally good? I'm with you. Okay, now freeze right here. The beautiful thing about this section is when it shows up on your midterm and your final, all you have to do is answer the question and you're done. I'm going to take you a little bit further because next time we're actually going to graph. So I want you to start thinking about the graph. Even though you don't have to, we're just taking like a little baby step towards it, okay? Okay, so draw your XY axis. Come out here to, come up to a 5. Then I want you to take your red pencil or your pen or whatever you're doing. Did I talk about the red? Yeah. Okay, so dash the right and dash the left, but I want you to leave the center open. Someone tell me why the center is open. What might happen? Go ahead. You might cross it. And I don't want to make it solid and then you go to cross it and then you're panicking because you're crossing a dashed line, okay? This is what you need to know, and I really think this is the #1 reason people can't graph it, right here. They don't understand what non-vertical means. It's an end behavior. So everybody look, this is big connection right here. As x gets big, where's your graph going? Right there. As x gets small, where's your graph going? Right there. Now, and then the middle part, I don't know. I'm going to figure that out. But I know that I'm going this way. Who says I understand? Okay, one more thing I want to say. See how I've written those green lines above? Maybe it's below. I don't know. But I do know that it's definitely going to that line. So it might be above and it might be below, but it's definitely going there, end behavior. If I drew an end behavior arrow on this problem, my end behavior would literally look like that. Who says I get that? Okay, yay. Yes, honey.
So when you get to drawing the graph, does it matter if you do the dash all the way through the graph?
You can do it however you want. I will do it how I feel like you're going to be the most successful. So we'll get there next time. Sometimes it crosses, sometimes it doesn't. We'll decide, and then you'll graph it accordingly. That's all I'm going to say for now. Okay, good. Okay, question B. Find the non-vertical. We're always going to check for horizontal first. So how do you do that? Biggest over biggest. So that's 2x squared over 4x squared. You guys, that's best case scenario. If they're the same, it's the easiest. You don't even have to remember anything. Except for, can you cancel those x squared? You should know that answer. Yes. And is this y equals 2, guys? Is that what you get? What is it? 1/2. Okay. That's your answer. Literally, that's your answer and you're done. Okay. Let's take it one step further. So draw your xy axis, go up to a 1. Take your red writing utensil, draw the left, draw the right, leave the center open. What does that mean? That means your end behavior is going flat out that way and flat out that way. Might be above, might be below. We'll figure that out later, but I know that's where it's going. Who says, I am 100% great right now? Let me see. Feedback. We okay? Good? Okay, question C. This is where it gets a little tricky. Okay? Biggest over biggest. That would be 2x over x squared. They are not the same. You have two options right here, guys. Listen, okay? You can memorize it or you can figure it out. I'm going to show you how to figure it out. And then we're going to write some work, but you don't always have to write the work. The bottom exponent's bigger than the top. Don't look at the guidelines I gave you. Use your brain. Is it none, meaning it's an oblique, or is it y equals 0? Which one is it? The bottom is bigger than the top. None, let's say it a different way. The bottom's bigger than the top. Oblique or y equals 0? Which one is it? Y equals 0. Okay, so write down y equals 0, and literally if you just had that memorized, you'd be done. Okay, now I want to show you something really fast. Okay, do a quick table. You don't ever have to do a table. Never. We're just doing it on this example so I can connect with you, okay? The end behavior, the non-vertical asymptote, as x gets big and as x gets small, where does my graph go? Okay, take your x and start with a 1. Then make it bigger. 2, 3, 4, 10,000. I know that was a big jump. If you reduce x over x squared, that gives you y equals 2 over x. You can reduce that. This 1x cancels with one of those, and it's y equals 2 over x. So I'm going to take this equation, and I'm going to plug in those values. Watch. 2 over 1, 2. 2 over 2, 1. 2 over 3, 2/3. 2 over 4, 1/2. 2 over 10,000. It could be 2 over 1,000,000. As the x gets big, the y's get closer and closer and closer to, tell me, 0. That's why it's y equals 0. So if the bottom's bigger, it approaches 0. That's your answer. Okay? All right, let's move to D. Biggest over biggest. X to the third over x to the second. If they're not the same, it's either oblique or y equals 0. Which one's this guy? Is it y equals 0 or oblique? Oblique. So read the question. Find the horizontal, it says determine the non-vertical actually. So the horizontal asymptote would be none, and it would actually be an oblique. I need you to understand that the non-vertical is either horizontal or vertical, never both. Never two, just one. Okay, so it's going to be an oblique, and that's all I'm going to say for now. Just the connection that our asymptote is oblique. Look right here for 2 seconds. The end behavior of this graph is not this. It's going to be this, or it's going to be this. And we're going to figure it out in just a second, but it's definitely not this. Who says I understand? Okay, there was something else I was going to tell you. Listen to this question. Listen and think. A graph can have two horizontal asymptotes. Don't shout that out and listen. A graph can have two horizontal asymptotes. Guys, the purpose of a horizontal asymptote is where your graph goes when it's big and when it's small. So if you have two of them, like stacked on top of each other, is that a thing? Can you go two places? Look right here. Draw an XY axis, or we do that. Well, nah, just look. Look, here's one. There's another one. As X gets big, it approaches there and there. Is that a thing, yes or no? Is that possible to have two horizontal asymptotes? Everybody? No. Can't go two places. So you either have one horizontal or you have one oblique, but you only have one horizontal or oblique, never two horizontals, never two of anything. Who says gotcha? Okay, great. Okay, now we're going to find an oblique. Here's how you find an oblique. You do long division. You throw out the remainder. And here's your setup. You put the bottom on the outside and you put the top on the inside. Okay, question 4. Find all the asymptotes. So everybody go vertical asymptote, non-vertical asymptote. Don't look at your notes. Make yourself remember. When you do your homework, don't look at your notes. Make yourself remember. Everybody in the room, how do you find a vertical asymptote? Tell me. Bottom. The bottom, right? So X equals 1. Even asymptote or odd, everybody? Odd. Because you have 1 X minus 1. Non-vertical. We're going to check if it's horizontal. Biggest over biggest. That would be 2x squared over x. It's not going to be like y equals 5 or something like that. It's not sweet and easy. The top is bigger than the bottom. It's either oblique or it's y equals 0. Which one is it? Oblique. So now we have to find the oblique. So you take the bottom of that fraction, which is x minus 1. You divide it into the top, which is 2x a second plus 3x plus 1. What I'm about to say is so important. This is why, you know how I get frustrated when you guys are like a problem ahead of me? There are so many details, especially in this lesson. So stay with me. You're going to miss these, okay? Look on the outside. The biggest exponent is a 1. You have to have a 1, and you have to have a constant. And I do. I have an exponent of 1, and I've got a constant. Look at the inside. Biggest exponent is a 2. You have to have a 2 and a 1 and a constant, which I do. If you're missing anything, you have to fill in placeholders. Okay, we'll deal with that in a second. Okay, what do I multiply by x to get 2x to the second? That would be 2x, right? Here's where people get confused. Look what you're going to do. You're going to take your 2x and you're distributing it across x minus 1. So 2x times x is 2x squared. 2x times a negative 1 is a negative 2x. Tell me what to do now, everybody. You subtract, which means change the signs. Yes. So these are negative. That's a positive. The first guys will always cancel if you did it right. 3x plus 2x is a 5x. Tell me what to do now. Bring down the 1. Start it again. What do I multiply by x to get 5x? That would be a 5. Distribute, and you get 5x minus 5. Change your signs. First terms cancel. You get a 6. Now let's talk about this. There's nothing more to bring down. So the 6 is the what? The remainder. And what do we do with the remainder? Throw it out. So your non-vertical asymptote is y equals 2x plus 5, and you're done. Is the right side and the left side of your graph going to look like this? Tell me. No. That's horizontal. This is not horizontal. Your graph is going to look like this, right? Because it's a line with a positive slope. Okay, take your pencil. Let's do a quick sketch. XY axis. Go to an x value of 1, dash it in. At the top of that, write the word odd. How many pieces am I going to have to my graph, everybody? 2 pieces. One on the right, one on the left. It's going to start getting complicated, so just keep those straight. Remember, 2 pieces is all I'm going to have. Go up to a 5. Make a dot. The slope is up 2, right 1. Down 2, left 1, down 2, left 1. I'm going to dash that guy in. Leave the center open. Why am I leaving the center open? Somebody answered that question. It might cross. It just replaced my horizontal. Okay. One more thing that I know about this picture is this. Look, as x gets big, my graph goes up there to that oblique. As x gets small, where does my graph go? Up, down. Tell me where. Center, where? Down. Goes right there. Now we got to just figure out the middle stuff. Okay. Who says gotcha? Let me see. Okay, great. By the way, we'll wait for a second. Find the oblique or the slant asymptote. We're going to do more. We're going to do vertical asymptote, non-vertical asymptote. That's how they're going to ask you. If they say, they won't say find the horizontal, find the oblique. They'll just say non-vertical. Okay, vertical asymptotes, everybody come from where? Bottom. So you get x equals 3, even or odd? Odd. If you just say 3, my vertical asymptote is 3. How many points will you get for that? 0 points. It's x equals 3. It's a line. Non-vertical, you don't even really have to show any work to determine what it is. Look, squared on top, first on the bottom. Top is bigger than the bottom. It's either oblique or it's y equals 0. Which one is it? Oblique. Now let's find the oblique. Everybody go x minus 3 on the outside. On the inside, go x squared. Do me a favor. Don't write anything. Don't say anything for just a second. Just watch. Okay? What do I multiply by x to get x to the second? X. Distribute x to the second minus 3x. Change my signs. Those cancel. I get 3x. There's nothing more to bring down. The 3x is my remainder. My non-vertical asymptote is y equals x. Wrong. That's wrong. Why is it wrong?
You don't have the placeholders for the missing values.
Yeah. Look at the outside. You have an x to the first and a constant. You're great. Look at the inside. You have a squared. Remember, once that highest exponent's established, you have to have the 1 below that, and you have to have a constant. So there is no x. So fill in 0x and then fill in a 0. Watch how much difference it makes. Now put your x up at the top. Distribute x to the second minus 3x. Change your signs. Bring down the 3x. Is the 3x the remainder? No. What do I do now? Pull down the 0 and do it again. What do I multiply by x to get 3x? That would be a 3. Distribute 3x minus 9. Change your signs. Those cancel. I have a 9. There's nothing more to bring down. What do I do with the 9? Forget about it. Non-vertical is y equals x plus 3. Done. Who says I get this lesson? Raise your hand. Let me see. Yay. Doesn't that feel amazing, right? Draw an xy axis. Everybody go to x equals 3. Dash in your line. Y equals x plus 3. Go up 3. Make a dot. Then I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. I can also go down 1, left 1. Guys, I know it's going to hit the y-axis over there, or pardon me, the x-axis over there at a -3. So it's going to look something about like that. Here's what I know. How many pieces to my graph? Tell me that. 2 parts, right? This guy's odd. Oh, I shouldn't have filled in the center. We'll talk about that more next time. The other thing I know is as x gets big, my graph goes up here, and as x gets small, my graph goes down there. Okay? All right, holes. The only time, did you groan? So let me just tell you this. I've never one time seen Weber State give you a hole, give my students a hole. Never. I will give you holes, maybe, but I don't think Weber will. Why do I still potentially do it? Because I have to have you ready for everything. I don't know what they're going to give you. But I think the chance of you getting a hole on your midterm or final, it's as close to 0% as I could say. Okay? The only time you're going to have a hole is if something reduces. That's the only time you're ever going to have a hole. The hole is going to be written as x comma y. And the way that you find it is you take what reduces and you set it equal to 0. And that's the x coordinate of your hole. Okay, let's go ahead and do this. Find the hole. But there's way more things that we're finding besides the hole. So answer the following questions. Okay, we haven't done this yet. Step number 1 is always to factor. Always. So I'm going to take that original graph and I'm going to write it as x plus 1 times x minus 1 over the bottom goes to an x and an x. The 2 goes to a 2 and a 1. Signs are the same. They're both positive. Step number 2 is always to find the domain. How do you find the domain? Everybody just shout that out. What do you do? Bottom, right? So we're going to say x cannot be equal to -1. X cannot be equal to -2. There's my domain. The third step is to reduce. X plus 1 cancels with x plus 1. The fourth step is to write the reduced equation. So your new equation is now y equals x minus 1 over x plus 2. Write a note to yourself out here on the side and say, use this equation from now on. Okay? All right. Step number 5, hole. If there's a hole. Did anything cancel? Yes. So I have a hole. Take the x plus 1, the thing that canceled. Set it equal to 0, you get a -1. So my hole is -1 comma something. How do I find the y coordinate of the hole? Somebody tell me how to do that. You plug it in. Where do I plug it into? The reduced equation, right? So everybody write. I really should say, do you see how that says f of x? I really should keep that f of x. So let's write that as f of x. So now everybody write down f of -1 is equal to -1 minus 1 over -1 plus 2. That's a -2 over a +1, which is a -2. There's your hole. Now let's do vertical asymptote. Okay, vertical asymptote comes from where?
Bottom.
The bottom. So it's x equals -1, x equals -2. Wrong. It's a common mistake. It's wrong. Why is that wrong? Go ahead, sweetheart.
That's from the original equation.
That's from the original. You have to use the reduced. You're exactly right. Somebody talk to me about that guy. That's the guy that shouldn't be there. Tell me about him.
It's a hole.
That's a hole. Yes, it's a restriction. X can't be a -1, but it's not a vertical asymptote. It's a hole. I just found that. So that should not be there. You use the reduced equation. Who says I gotcha? Okay. Non-vertical. How do you do non-vertical? How do you do it? Biggest over biggest, right? So it's going to be y equals x over x. I used my reduced equation. That's the best scenario. When they're the same, it's so easy. That's just going to give me y equals, tell me, y equals 1. Done. That's it. Okay, let's graph it. XY axis, I always draw my asymptotes first when I graph, guys. Come over here to x equals -2. I didn't say if that was even or odd. What is it? It's odd. So at the top of that, write down the word odd. Y equals 1. Put a mark right there. Horizontal line. Center is open. I know I have a hole at -1, -2. Left 1, down 2, hole. There's one more thing that I know about this graph. I know as x gets big, my graph's going that way. As x gets small, my graph's going that way. Good? Okay, yes, sweetheart.
Do we have to draw this graph on this?
You don't have to do any graphing, none. But what happens is when Friday comes, people freak out. And so I feel like if I start getting you to think about the graph, then maybe you won't freak out on Friday. So I'm just trying to ease you in. But there is 0 graphing on today's homework. Okay. X-intercept, y-intercept. It feels like we've done this on every single lesson, right? We just keep doing it and doing it and doing it. It's a little bit of a twist on this one right here. Okay, just so you guys know. To find the x-intercept, I let y be 0. To find the y-intercept, let x be a 0. You guys, the y-intercept is so easy. You just look at the equation, get rid of anything that has an x in it. What's left? 1/6. Done. To find the x-intercept, you let y be a 0. Everybody go 0 equals 2x plus 1 over x squared minus 5x plus 6. Now what I want you to do is to just sit back and watch and listen. Okay? What I'm about to say is difficult to understand. It's difficult to explain. But if we can connect, it will save you so much work and so much time. Okay, so everybody listen. I have a fraction right there equal to 0. If I have the fraction a over b equals 0, that's basically what I have up above. Somebody tell me what I know about a or what I know about b. If a fraction is 0, what do I know about those values? Go ahead, honey.
A has to be 0 and b can't be 0.
That's so good. That's so perfect. A has to be 0 and b can't be 0. Everybody look right here. 0 over 5. Don't write this down. 0 over -13. 0 over 1,426. What are all of those equal to?
0.
They're all 0. The top is 0, then the whole thing's equal to 0. Who says I understand that? Okay, so listen what I'm going to say to you and what you're going to answer. Okay, I'm going to say this. To find the x-intercept, I let y be a 0, which is the same as letting the blank be a 0. What's the blank? The top. Yep. So all you have to go is 2x plus 1 equals 0. 2x equals -1. Divide by 2. X equals -1/2. If you forget that, you can just cross multiply and then solve. It all ends up the same, but it's so much quicker if you can remember that little trick. Okay, let's do the next one. To find the x-intercept, let y be 0. To find the y-intercept, let x be 0. The y-intercept is a breeze. Let's do it right now. Okay, so that's a 0, that's a 0, -4 over -1, +4, done. To find the x-intercept, let y be 0. That's the same as letting what be a 0? Everybody tell me. The top. So everybody go x squared minus 4 equals 0. That factors to x plus 2 times x minus 2, which gives you x equals -2, x equals +2. Did you see how I wrote them separately for you, right? So your x-intercepts are -2, 0 and 2, 0. The exponents are both 1s. They're both odd. They're both going to cross. That's the connection from last lesson. We're going to put this whole thing together pretty quick. Question?
What
Good?
I was going to say is if you, instead of factoring it out, can you still do that? Or
Yes, you can. I just feel like it's easier for me to explain to you with other things. You know what it is? It's the whole cross or bounce that's easier to connect if you factor. But the other way you think about it, hon, is you say, how many times, if you square root it, look, because I prefer square rooting for sure, then you would say, how many times is 2 a solution? 1, 1 is odd. How many times is negative 2 solution? 1, 1 is odd. So it's the same thing, it's just not as slick as that, okay? Yeah. You good? Okay, great. Okay, this negative 1/2 0, by the way, you only have one of them, so that will cross the x-axis. Okay? All right, here we go with question C. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. The y-intercept is so easy. Get rid of this x. You have 2 over negative 1. What's 2 over negative 1, everybody? Negative 2. Okay, let's do the other one. To find the x-intercept, let y be 0, which is the same as letting the top be a 0. So that's 2 equals 0. Is 2 equal to 0? No. So then some people are like, oh, then the x-intercept would then be 0, 0. That's not true. If that was an x, then you'd have x equals 0, and then it would be 0, 0. What is it?
None.
It's none. Yep. So you get rid of your little setup right there. You write the word none, and you're done. You guys are awesome. Okay, next one. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. If x is a 0, gone, gone, gone. What are you left with? Negative 5 over 2. Done. To find the x-intercept, let y be 0, which is the same as letting the what be a 0? The top. Everybody go x a second plus 2x minus 5 equals 0. This happened a couple, maybe 4 semesters ago. What's the problem? It won't factor. So do I say none?
No.
What do I do? Quadratic. Here we go. X equals negative 2. Plus or minus the square root of 2 squared is 4. Minus 4 times 1 times negative 5 all over 2 times 1, which is a 2. Do I have permission to write this in decimal form? No, I don't have permission. How would I have permission? If it said write it as a decimal. It did not, I don't have permission. Grab your calculator and you're going to put that in, just that yellow stuff. When you put that in, you get 24. Can I now reduce it to this? Negative 1 plus or minus the square root of 12 over 1. Is that okay? No. What's messing up us not being able to do that? The 24 is in. Can't do it, right? So you take the 24 and you break him down. So 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. These two 2's come out. So you have x equals negative 2 plus or minus 2 square root of 6 all over 2. How many people in this picture? 3 people. Is there a number that goes into all those people? 2. So x equals negative 1 plus or minus 1 square root of 6 all over 1. It's right. It's just awkward. But it's full credit. Why is it awkward? Someone raise your hand and tell me one reason it's awkward. Thanks, honey. Oh, why is that weird? Dividing by 1 doesn't change it. Yeah, everything's over 1. So don't need it. There's one more awkward thing. What is it? Why not? You don't need the 1 in front of the radical because?
It doesn't change.
Because, why doesn't it change it?
Because it's always going to be there.
Because it's multiplied. If I have a 5 and I multiply by 1, it's still a 5, so it doesn't change it. You know what people do? They drop that guy. That's because that's added. Adding 1, or in this case it was subtracting 1, does change, okay? So you're going to go negative 1 plus the square root of 6 comma 0, negative 1 minus the square root of 6 comma 0. How many, do they cross or do they bounce? It was a squared, and I got 2, so each of them is just once. 1, 1 is 2, right? So those both cross. Who says gotcha? Okay, great. Okay, example 8. Here we go. Find the x-intercept. Find the y-intercept. Find the vertical asymptote. Find the non-vertical asymptote. To find the x-intercept, you let y be 0. To find the y-intercept, let x be a 0. Let's go back to x-intercept. Y is a 0. That's the same as letting the blank be a 0. Fill in the blank. Top. 4, 0. To find the y-intercept, let x be a 0. Gone, gone, gone. What do you have left? negative 4 over 5. Oh, I should have done this to begin with. It's not a big deal. I want you to factor it, very first thing. Okay, x and x, didn't make a difference on that, it's fine. 5 and 1, signs are the same, both negative. Here's what I really, really, really need you to understand. This is big. Yellow, pink. They are exactly the same thing. It's exactly the same thing. One's multiplied out, one's one's factored. Who cares? It's the same thing. So when I'm finding the x-intercept, go back to x-intercept. Where's it easier to let the top be a 0? Yellow or pink? They're the same, so it doesn't matter. But look at the y-intercept. I have to let x be a 0. Where's it easier to let x be a 0? Yellow or pink? Tell me. Yellow. Knock them out. Your answer's staring at you. So you've got to know which one's easier. Let's do the next one. Vertical asymptote. Where does it come from? Bottom. Which one's easier, yellow or pink? Pink. It's already factored for you. It's basically like done. Said x minus 1 equal to 0, get x equals 1. It's an odd vertical asymptote because the exponent's a 1. The next guy's x equals 5. This is also odd because the exponent's a 1. Who says I understand? Okay, non-vertical. How do you find it again? Biggest over biggest. Look at the pink, x over x. Right or wrong? It's not right. You have to look at the multiplied out. You have to look at the biggest exponent. The bottom's not x, it's x squared. Don't look at your notes. If they're not the same, it's either oblique or 0. Which one's this guy? 0. Wonderful. You guys are amazing. Okay, let's do this one. X-intercept, y-intercept, vertical asymptote, non-vertical up for those intercepts being ordered pairs so you can get credit. What's the first thing I want you to do? Factor. So it's going to go to x and x. 12 is going to go to 3 and 4. Signs are different. Biggest is a negative. Are these yellow and pink the same thing or are they different? They're the same. They look different. It's the same. X-intercept. Y is a 0. It's the same as letting the top be a 0. Yellow or pink? Who's easier? Okay, let me say something really fast. Everybody freeze right here for 2 seconds. Freeze right here. If you never can make the decision which one's easier, are you still going to potentially get it right? Yeah, it's just more work, right? So is it easier, okay, look, is it easier to solve this or is it easier to solve this? Right or left? Right, it's done. So this is just 4, 0 crossing, negative 3, 0 crossing, done. You'll still get the same answer. It's just more work, and we don't want to do more work if we don't need to. Okay, to find the y-intercept, you let x be a 0, yellow or pink? Yellow. Get rid of all the x's. Negative 12 over negative 1, positive 12. Vertical asymptote, yellow or pink? Doesn't matter. Doesn't matter, right? Both the same. X equals 1. How many times is it down there? 1. Odd. Non-vertical. Where do I have to look? Where do I have to? Yellow. So that is x squared over x. If they're different, it's either y equals 0 or it's an oblique. Tell me. Oblique. Do you see how you already know? Who's like, I already know. I already have it memorized. So just do your homework just like you've done the lesson. Homework's done. It's memorized. It's in your brain. Right? Okay, let's do oblique. X minus 1 divided into, inside of there, should I put x minus 4 times x minus 3 or x plus 3? Of course not, right? It's the multiplied out version. Am I missing anything? Do I need placeholders? No. What do I multiply by x to get x a second? That would be an x. Distribute x a second minus x. Change your signs. Cancel, cancel, negative 12. Nothing more to bring down. If this guy has 2, this guy has to have 2. But there's nothing else to bring down. So I'm done. The negative 12 is the remainder. Throw it out. Non-vertical, y equals 0. For this being the most important lesson in this class, I feel like you guys are awesome. Like you are good shape. Who says, yep, that's me. I'm in good shape. Okay, yay. Okay, find the quotient. Yes.
On that last one, why is it y equals 0?
It is not. It is not. What is it? Thank you, honey. It's y equals x. Thank you. That would have been really bad had you not corrected me, honey. Thank you. Y equals x. Okay, find the quotient. What is the definition of quotient?
The answer to a division.
The answer to a division problem. So how do I do this?
Divide.
It's just long division, right? Outside is x minus 3. Inside is 3x to the second minus 5x plus 1. What do I multiply by x to get 3x squared? 3x. Distribute. 3x to the second minus 9x. Change my signs. First things cancel. 4x. Bring down the 1. What do I multiply by x to get 4x? That is 4. Distribute 4x minus 12. Change your signs. Those cancel. 13. This is important. This should be highlighted. Is it highlighted?
No.
It's been there, and recently. So I would just make sure I knew it. The quotient is this guy right here without the remainder. So the answer is 3x plus 4. And there is no y equals with it. It's just that top stuff. Okay? That's it. Okay, before the bell rings, freeze right here, and everybody come right here, and let's do a quick xy axis. Okay? I always graph asymptotes first because it sets me up. Okay? So x equals 1, come over here, put a mark, dash it. At the very top, put odd. How many pieces to my graph? 2 pieces. The graph y equals x looks like this. Hits the origin at 0, and it goes like that. That's the line y equals x. Up 1, right 1, up 1, right 1, pencil at the origin. Okay? What else do I know? I know it's going to hit over here at 4, 0, and it's going to cross. I know it's going to be over here at a negative 3, 0, and I know it's going to cross. What else do I know? I'm going to do this and see if I freak you out. Can I do it?
Sure.
Watch. As x gets big, my graph goes here. As x gets small, my graph goes here. I think I'm going to stop. I think I'll freak you out if I do it. We'll wait for Friday. Wait for 2 seconds. Look at that graph. Who says I totally get that everything that you just did? Good? Okay. That's it. You guys are awesome. Have a wonderful day. Be ready for Friday.